Number 3, the figure above shows the graph of the piecewise linear function f for negative 4 to x to 12. The function g is defined by g of x is equal to the integral from 2 to x of f of t. So before I even start reading the problem or doing the problem, I'm going to go ahead and up here. So g is equal to the integral of f, which is going to be the area under the curve. Okay, g prime is just going to equal f, which is the curve, and g double prime will equal f prime, which will be the slope. All right, just a little FYI, they are going to give you 1 point for getting this down right here. So you definitely want to make sure you do that, and you actually do want to connect g and f together, which I did right there. Okay, so that was worth 1 point already. Okay, part A, does g have a relative minimum, a relative maximum, or neither at x equals 10? So if I'm looking for minimums and maximums, I do need a g prime chart. This one I'm only concerned about x equals 10 though, and I do notice that if I'm looking at g prime, it is the curve. I do notice that g prime does equal 0 there, so I'm just going to be concerned about 10. I notice to the left, immediately to the left of 10, my graph is below the x-axis, so g prime will be negative, and after 10 it is also negative. So in order to have a relative minimum, g prime would have to go from negative to positive. Relative maximum, g prime would have to go to positive to negative, so neither. So g has neither, and if I want to justify my answer, it would be because g prime does not go from negative to positive or positive to negative at x equals 10. So that would be why. That was worth just 1 point. So you either got it right or you didn't, but you had to have the justification and the neither to get your point. Okay, part B. Does the graph of g have a point of inflection at x equals 4? So similar process here, but this time if I'm looking for points of inflection, I'm going to be referring to g double prime, and I really only care about 4 because that's the only one they asked me the question about. So if I look at g double prime of 4, let's look to the left. So here's 4. We're going to be looking at the slopes. So if I look at the slopes before 4, immediately before 4, I notice that they are positive because that graph is going up, and then after 4, the graph is going down. So does it have a point of inflection at x equals 4? Definitely. So I'm going to say yes, and that would be because g double prime changes sign at x equals 4. Okay, that was also worth just 1 point. We had to have the yes and a good reason why. Okay, C, find the absolute minimum value and the absolute maximum value of g on the interval negative 4 to 12. Justify your answers. Okay, if we're looking for absolutes, we want the critical numbers, and then we get to do some testing. So if I want to find out where g prime equals 0, I'm going to be looking at the curve. So my zeros are at negative 2, 2, 6, and 10. So at x equals negative 2, 2, 6, and 10. Okay, one thing that I'm going to do, I'm just crossing off 2 and I'm going to cross off 10 because those could not be candidates, because if I'm positive and then positive, I couldn't have any sort of maximum or minimum. So since the graph is not even changing sign there, the g prime, we don't really need to consider it. But if you go ahead and test that, go right ahead. So I know that I need to find g of negative 2. I'm going to find g of 6. I'm going to find g of the endpoints. So I'm going to find all of those. All right, so here we go. To find g of negative 2, I'm going to plug my negative 2 in for my x right there. So it's going to be 2 to negative 2 of f. Well, we know we're not allowed to go from 2 to negative 2, so it's going to be the opposite of negative 2 to 2. So if I look at from negative 2 to 2, that is a triangle. So it's going to be negative. And then my triangle is 1/2 times the base of that triangle would be 4. The height of that triangle is also going to be 4, and that will equal negative 8. Alrighty, g of 6 would be the integral from 2 to 6 of f, and that's totally set up fine. So 2 to 6 is also a triangle, which is going to be 1/2 times 4 times 4 once again, 1/2 times 4 will be 8. Then g of negative 4 will be going from 2 to negative 4 of f. Well, we know we're not allowed to do that, so it's going to be the opposite of the integral from negative 4 to 2. So if I go ahead and do this, the area under the curve from negative 4 to positive 2, I already found from negative 2 to 2. Oh, that doesn't help me. Okay, never mind. Negative 4 to 2, I have two triangles going on there, so it's going to be the opposite. The first triangle, it's below the x-axis, so it's going to be negative. So negative 1/2 times 2 times 4, and then plus the area under the curve from negative 2 to 2 is also going to be a triangle, 1/2 times 4 times 4. Okay, and then when we work that all out, we should get, this ends up being 4 inside, so this negative bumps it into a negative 4. Okay, and then g of 12 is the area under the curve from 2 to 12. So to get from 2 to 12, first of all, I see the triangles going from 2 to 10 are going to cancel each other out, so I don't really care about those. And then that last triangle is negative, so it's going to be negative 1/2 times the base of that one is 2, and the height of that one is 4. So that one will end up giving me also negative 4. So when it asks for an absolute minimum and an absolute maximum, the absolute minimum value that I got when I calculated those was negative 8, and the absolute maximum that I got when I calculated those was, looks like, negative 4. Oh no, wait. Oh no, it was 8. Sorry. I thought that was incorrect. Okay, so the points that we would have gotten for that one, this was 4 points. So if we decided that negative 2 and 6 were candidates, so we tested those, we got 1 point. We don't care if we get the right answer, but as long as we tested them, we got a point. If we also tested negative 4 and 12, we got another point. So not even doing any work, just saying that's what we want to do, we got another point. Okay, and then our answers, we should have gotten a negative 8. So we got 1 point for that and 1 point for that. However, to get these points, we had to have shown work to get there. So that big whopping problem was worth 4 points. Okay, part D. For the interval between negative 4 and 12, find all intervals for which g of x is less than or equal to 0. So remember, g of x is this. It's the area under the curve. So we want to find out, from what value to what value, what could I put in for x so that my area under my curve is going to be negative. Okay, so on this one, I'm just going to start way at the left of my interval. So what if I plugged negative 4 in here? So if I plugged 2, negative 4 in here, we already found out, did we find that one? I believe we did. We found out that that had a negative area. It ended up being negative 4. So negative 4 has a negative answer. All right, so let's say I now did from 2 to 2. So that is going to be 0. So when it says find all intervals for which g of x is less than or equal to 0, so from negative 4 to 2, it goes from a negative to 0. So that would be one interval where that area is going to be less than or equal to 0. So negative 4 to 2 is one of those intervals. Okay, so now let's keep going. So let's say I now go to the next piece, which is 4. Okay, if I do from 2 to 4, my integral from 2 to 4 is actually going to be a positive, so that's not going to be a negative interval. From 2 to 6, that still is positive because everything is above the x-axis. If I go from 2 to 8, I do have a negative part, but the still overall net gain is going to be positive. If I go from 2 to 10, 2 to 10, I just end up getting 0. So here we go. There's one where I get an area that's less than or equal to 0. And then if I try 12, 2 to 12, my answer, because this was equal to 0, if I go all the way to 12, I'm going to get a negative answer. So another interval, just negative, not negative 1. Another interval where the area is going to be negative would be from 10 to 12. Okay, that part was worth 2 points. You got 1 point for the first interval, 1 point for the second interval. So hopefully you're able to maybe squeak a point with no work necessary. You just got it or you didn't. So that is problem 3.